Let's look at another equation here, another quadratic equation. It's just like the last one, right? I made it too easy. So what do I need to do? This is the only place I have x, so we're going to do what? Isolate it. How do you do that? Move the 1 over. So we have x minus 4 squared equals 9. I've got the square by itself, and how do I undo that square?
Square root.
I use that square root property. Don't forget your plus or minus, right?
Yes.
So that means I have what here? I've got x minus 4 is equal to plus or minus what?
Square root of 9.
Square root of 9.
Well, the square root of 9 is just 3, isn't it?
Oh, yeah.
So now what am I going to do?
Move the 4 over.
Now when I move the 4 over, where did I say this needs to go?
Go
In the front.
in front of the plus.
So it's a positive 4. It goes in front of the plus or minus 3. And the reason I stress that it goes in front of the plus or minus, because 3 is the only guy that has that duality of signs with that plus or minus. And if you move the 4 behind the 3, you may do something dumb like plus or minus 7. And that would be wrong.
So this is a quadratic equation that has 3 answers.
Where are you getting 3 answers?
4 plus or minus 3. That's 3
Well,
answers.
understand what this means if I were to separate these answers. That means that x equals 4
Plus 3.
Plus
4
3,
minus 3. So it'd be
or
X.
x equals 4 minus 3, because quadratic equations, normal quadratic equations have how many solutions?
2.
2. So here, x is equal to 7, or x equals what?
1.
X equals 1. Now, a question has been raised about checking solutions here. When we had to worry about checking solutions was when we had things that were rational, where the x's were in the denominator, because you couldn't have a restricted value, right? We also had to check with radicals, because when I had the square root symbol, the square root symbol only returned to me the positive value, right? So there was some limitation there. But I don't have anything like that here when I've got things that are quadratic. The 2 answers I get should be the 2 right answers. Because think about this, if you were to graph this guy,
So we do have to work it down to x equals 7 and x equals 1.
right, you have to get it totally simplified because this is not done. There's more work to be done here, and you see that when I separate those, there's more work.
The last one, there was nothing else I could do, right?
Right, the last, this was the last guy right here.
No, because square root of 7 wasn't.
Right, if I separate this and I say negative 13 plus the square root of 7, or negative 13 minus the square root of 7, there's nothing more that you can do in terms of simplifying. They just are. But with these, there is more that can be done. Now, we know these guys should be quadratic because look at what this guy is. If I said this is y equals, what do you know about the shape of this guy?
Parabola.
It's a parabola, and where is it located? Where has it been shifted?
1.
It's been shifted up 1 and over 1, 2, 3, 4, right? So it's opening up, and it's something like this. It's not perfect. I don't claim for it to be perfect. And then up here is 10, and so you've got this horizontal line. How many solutions do you have here? How many intersection points?
2.
You had 2 intersection points. When I had radical equations, I had something that was like this. Something that was on its side, right? So if I had a line that was going through it like this, there would only be 1 intersection point. I could have one that hits 2 times, but if I'd had this, I would also have this extra solution down here, right? But the square root would only return the positive values, not the negative ones as well. So that's why we had to go back and check to see if we would have something that was extraneous. But when things are quadratic, as long as you do the math correctly, you should get the answers that are correct. But if you're not sure, you can always plug them back in. If I plug in 7, 7 minus 4 is 3, 3 squared is 9, plus 1 is 10. I plug in 1, 1 minus 4 is negative 3, negative 3 squared is what?
9.
It's still going to give you a positive 9, right? Plus 1 equals 10. So that's what you're looking at there. The square root guide limits you to only returning that the positive square root. All right, let's do another one of these.
So, Mr. Craig, so we could simply see that when it's two numbers like that with the plus or minus, we know we're gonna have to work further, but if it has a square root.
If it has a
there's
square
nothing
root or if
outside
it has
of
an I. If it's complex or if it has a radical, you just simplify what you have and you won't be able to really separate that into two different numbers that are going to do more reducing like we have here.
Okay.
Let's look at this example right here. 2x plus 6 quantity squared plus 3 equals negative 13. Notice that the only place I have variable is contained within the square, right? When that's the case, that means the square root property is going to be involved. But before I use the square root property, what must I do first?
Move the 3.
I've got to move that 3 over, so when I do that, I have 2x plus 6 squared equals what? Do I have the square by itself? Yes, so now this is where I use the square root property. So what do I do?
Square it?
I don't square it.
Square root it.
Use this, yeah. Take the square root of both sides. Remember your plus or minus, right? Because if you forget the plus or minus, you're going to miss half your solutions, which means you'll miss half your answers. What do I have on the left side?
I, no, I'm just kidding.
I've got 2x plus 6 is equal to plus or minus. What's the square root of negative 16? The square root of 16 is 4. The square root of the negative gives me I.
See, I thought you were putting the I's that were inside on the outside.
What?
Like, the first one, it was negative 20, so we put the I on the outside.
Because the negative inside the square root gives me the I. Remember what we're seeing here for this guy. We're seeing this guy as the square root of 16 times the square root of negative 1. The square root of 16 is 4. The square root of negative 1 we defined to equal I.
Yeah, I get the I just don't get why in the first one it was on the outside of the square root.
This is outside the square root too.
I guess it makes sense. Okay.
Now how do I finish solving this guy?
Move the 6 over, divide it by 2.
So 2x is equal to
6 plus negative 6.
negative 6 plus or minus 4i, right?
Right, now divide.
Remember, you've got to move this guy, bless you, in front of the plus or minus. And then to finish getting x by itself, because we don't solve for 2x, we're not grocery stores where we have to do, oh, 2 of these for $1, just tell me it's 50 cents each, you know? Or I'm the only one who gets frustrated with that. Everybody. So what does x equal?
3 plus or minus 2I?
Negative 3
Oh.
plus or minus 2i. Do y'all agree? Now, I can box this guy because this is imaginary, this is complex. If I separate it, nothing else happens. And if you don't believe me, watch this. Doesn't matter because some of you don't believe
Some are
me.
non-believers. Non-believers.
If I were to separate this into my two answers, this is what I have. Can I reduce this anymore?
No.
Can I reduce that anymore? No. What you do see here, and this is an important concept for college algebra, these guys are complex conjugates. Right? Look how the real parts are the same. The imaginary parts have opposite signs. These are complex conjugates. So what you'll find out is that complex solutions for quadratic things will occur in conjugate pairs.